I know this isn't perfect, but I'm going to attempt a screen recording today. Let's see if this works. All right, so today we're talking about linear inequalities. This is day one, this is Monday. For most of these, you can just follow along. If you want to write things down, you can, but try to be a step ahead, not a step behind. First, what's an inequality? An inequality is a range of values. It's not one set number. Tomorrow we'll look at it on a number line, and that'll make a lot more sense to some of you. So it's an algebraic relation showing that a quantity is greater than or less than another quantity. An example would be the speed limit. If the speed limit says 70 miles per hour, you don't have to go exactly 70. You can go any speed up to 70. So your speed, x, is anything less than or equal to 70. You are allowed to go 70. You can't go 71, or you could get a ticket. Not that I've ever done that. Okay, so here are your four inequality symbols. The first two you've had for a long, long time. You have less than and you have greater than. Now here you can see it's both an equality and inequality in that it can be equal. This is half an equal sign. So this symbol is less than or equal to. This symbol is greater than or equal to. So the speed limit, you can go exactly 70 miles per hour. So you can be equal to that. Now, unfortunately, you don't get to see my awesome drawings of alligators, but I can draw some pretty good ones. You want to eat the bigger cupcake, the bigger piece of pizza. Eat whatever's bigger. Good way to remember which way we should go with this. Okay, so let's look at this. For each value of x, determine whether it is a solution to x is less than or equal to 11. So first we plug 9 in here for x. Is 9 less than or equal to 11? Yeah, of course. Is 5 less than or equal to 11? Yeah, of course. Is 11 less than? No. Is 11 equal to? Yes. Is 14 less than or equal to 11? No. So that's how you do that. Let's look at some other phrases, like at most, at least, more than, or in excess. So think of an example. Say, you are at most 13. Could you be exactly 13? Yes. Could you be less than that? Yes. So less than or equal to. At least, say you are at least 13. Could you be 13 again? Yes. So it has to be one of these two. Could you be 14? Yes. So here's at least. More than. If you are more than 13, can you be 13? No. So it has to be one of these top two symbols. More than is the same as greater than. In excess. If you are in excess of 13, that doesn't make sense. If you weigh in excess of 13 pounds, that means you weigh more than 13 pounds. So again, in excess would go with this symbol. Okay, here's the best hint I can give. If you do this, you're going to be exponentially better at this. Take the time to write down three numbers. Write the original number, write a smaller number, write a bigger number, cross out what doesn't work. I'm telling you, the longer you do this, the more you do this, this will help you keep it straight on paper instead of in your head. Let me show you. So, C is less than 2. Here's a straightforward one. So if I write three numbers, I write the number itself, 2, I write a smaller number, and I write a bigger number. I'm just going to use 1 and 100 today. Is 1 less than 2? Yeah. Is 2 less than 2? No. Is 100 less than 2? No. So we know the answer, 1, is the only thing that can work in here of these three examples. It's the only one in the range. So I know that we're going to gobble up the bigger number. Okay, 5 is greater than or equal to j. So I'm going to write the number itself, 5. I'm going to write a smaller number, 1, and a bigger number, 100. Notice I put it over here by the variable because the number itself is staying the same. Since C was over here on this example, I kept on this side and 2 on this side. Here, 5 is first and j is second. So that's why I did it on this side. Okay, so 5 is greater than or equal to 1? No. 5 is greater than or equal to 5? Yeah. 5 is greater than or equal to 100? Yeah. So my answer then, 5 and 100 both fit in here. 1 would not fit in here. F is at most 20. Okay, so again, put the number, smaller, bigger. 1 is at most 20? No. Hold on there. 1 is at most 20? Yeah. 20 is at most 20. Yeah. 100 is at most 20? No. So f is going to be less than or equal to 20. Sorry about that. Next example, Bob runs more than 3 miles every day. Let R represent the miles he runs daily. So I like putting my variable first when I can. So we're going to try the numbers 1, 3, and 100. Could Bob run 1 mile? No. Could Bob run exactly 3 miles? No, he runs more than 3. Could he run 100? Yeah. So the symbol I put in here, 100, is the only one that should work. So it's going to be greater than. The miles he runs daily is greater than 3. Okay, Karen runs no more than 5 miles each day. Okay, so let's try 1, 5, and 100. Could Karen run 1 mile? Yeah. Could she run exactly 5 miles? Karen runs no more than 5? Yeah. Could she run 100? No. So cross out 100. So we got to put a symbol in here that only 1 and 5 work for. Less than or equal to symbol. Okay. Translate this sentence into an inequality. The product of C and 6 is greater than negative 15. Okay, so we read left to right, so let's write it left to right. The product of C and 6. Product means multiply. The greater than symbol, negative 15. So C times 6 is greater than negative 15. Better yet, 6C is greater than negative 15. The temperature inside the lab refrigerator is less than 40 degrees. Use T to represent the temperature in degrees in the, okay, so T and 40. So let's try putting in our numbers again, 1, 40, and 100. Could it be 1 degree? Sure it could. Could it be 40? No. Could it be 100? No. That wouldn't be a fridge. So oh, it can't be exactly 40. It says it's less than 40. 40 is too warm. So it can't have an equal sign. T is less than 40. Okay, that's it for today. Show me you can do this. Go do this assignment in Alex. It's a 4-question assignment with those 4 topics. And then when you finish that, this week we are not doing 2 topics every day. This week we're doing at least 20 minutes in Alex each day for 3 days. So you'll owe an hour by the end of the week. There should be an assignment in there where that works. We just covered topics 1, 2, 3, 4. Those are the 4 that are on your assignment, your class practice that you're doing for today. Tomorrow we'll cover some of these other ones. These are all in your equations and inequality pi. So finish that assignment and then go into Alex and try to knock these out. All right, good luck today. Let me know if I can help.